We are discussing about GATE 1995 ECE paper, and this is 2 marks question related to electronics. It's a match the following type question related to BJT, bipolar junction transistor. One side it is given as the current gain increases, collector breakdown voltage increases, and the cutoff frequency increases. Okay, what you are going to do such that these things are going to be increases. On the other side it is given as the base doping is increased and the base width is reduced. Second option is base doping is reduced and the base width is increased. Third, the base doping and base width both are reduced. Fourth one, the emitter area is increased and the collector area is reduced. Last option is base doping and base width are increased. So what we are going to do such that first we will go for the current gain increases. Okay, so all these things, current gain and cutoff frequency, all are going to be related to BJT whenever it is acting as amplifier, and transistor act as amplifier only in active region. Active region means emitter base junction is going to be forward bias and collector base junction is going to be reverse bias, then only it act as amplifier. So transistor operation as amplifier is only possible with the help of base characteristics. If the base characteristics doesn't meet these 2 points, then it won't act as amplifier. Okay, the heart of transistor operation is only depends on base. The 2 important characteristics of base are: one is base is lightly doped, the second is base width is very thin. Okay, base is lightly doped and base width is very thin. And assume that one we are going with a BJT of NPN type. So emitter is heavily doped, so that we are going with N++. That is, emitter is heavily doped and collector is moderately doped, so that it is given as N+, and base is lightly doped, so that it is P. So N++, P, N+. According to the doping concentrations, emitter, base and collector are shown. And we are applying this VBE minus plus voltage. We are applying this VBE as minus plus, because NPN transistor we should make emitter base junction forward bias, so that it is minus plus. So emitter base junction, this will become forward bias, and VCB, the collector base junction, it is indicated with JC, has to be reverse bias. For that one, N side you must apply positive voltage of the battery, so this is plus and it is minus. So the transistor is in active region now, and because of this one, emitter base junction is forward bias. Because of emitter base junction is going to be forward bias, a large number of electrons are going to be diffusing into base. Okay, and out of that one, base is lightly doped, so that a very few recombinations are going to be taking place. And since the base width is very thin, okay, whatever the expected number of recombinations are also not going to do, because very thin implies nothing but the base width WB is going to be very small compared to diffusion length of base, that is diffusion length of minority carriers in base. So if the base width is larger than diffusion length, then only the number of recombinations whatever we expect, that will takes place. Otherwise, if you are not allowing that much width, at that time even that number of recombinations also couldn't take place, so that most of the electrons coming from the emitter will reach the collector. So by that time we can assume IC is approximately equal to IE. This is what we can say. So current gain, first of all we are interested in. Current gain is nothing but common base current gain is indicated with alpha, which is nothing but IC by IE, and common emitter current gain is beta, which is nothing but IC divided by IB. So, and alpha and beta are going to be interrelated, that is nothing but alpha is equal to beta by beta plus 1. Otherwise we can write it as beta is equal to alpha by 1 minus alpha. Okay, so based on this one, alpha increases, beta increases, so that implies nothing but if alpha increases, then beta also increases. So we can consider any of the current gain. So let us consider alpha. Okay, whenever you consider alpha value, alpha is equal to IC by IE. For the given emitter current, if you are getting more number of electrons according to this diagram, if more number of electrons are which are coming from the emitter will reach the collector, that implies nothing but that is going to be giving the more current gain. So for given IE, for given IE, that is emitter current, if IB is small, then IC is increases. So IB is small is nothing but if IB reduces. Okay, IB reduces, that is if IB reduces, at that time IC can be increases. How the IB will reduce? Based on two conditions. Okay, the base width, if the base is lightly doped and the base width is going to be very thin. So based on these two conditions, if you make very much, doping concentration is going to be reduced and base width is going to be reduced. By that time IC is approximately equal to IE. That is what we will get. Okay, so that can be written in this way. So that can be written in this way. Look at this one. Current gain can be increased either by decreasing base width, okay, or by decreasing base doping concentration, okay, or by increasing emitter to base doping concentration ratio. By increasing emitter to base doping concentration ratio. What is meant by this one? Okay, emitter to base doping concentration ratio is nothing but you can specify like this. IE is equal to, we can expect IE is equal to IC plus IB. Okay, so by that time if IE is going to be very large, if IE is going to be approximately equal to IC, at that time IB has to be less. IB should be very large. That implies nothing but less number of carriers. So base has to be very lightly doped, emitter has to be very heavily doped. So that implies nothing but emitter to base doping concentration ratio has to be increased. Okay, so similarly current gain can be decreased, that is can be reduced by going with the opposite conditions, either by increasing base width or by increasing base doping concentration or by reducing emitter to base doping concentrations. Okay, so for the option A, what we can say is nothing but for option A, the answer is current gain increases if the base doping and the base width both are going to be reduces. This is the answer for A. So A is going to be related to C. So you can write it as A3. Next, collector breakdown voltage. Collector breakdown voltage is nothing but breakdown voltage across collector base junction in this case. So for a PN junction we can say like this. Okay, for a PN junction, in case of a PN junction, for a given power dissipation, PD, we can write it as V into I, voltage across that one and current flowing through that junction is going to be giving the power dissipation. So if the rated power dissipation is going to be constant, by that time you can increase, okay, the breakdown voltage by reducing the collector current. So across this one PD rated, which is nothing but PD maximum, PD power dissipation maximum, which can be written as V breakdown voltage at collector into collector current. So collector current, as collector current decreases, by the time PD maximum for the given power dissipation, breakdown voltage across collector has to increase to maintain the power dissipation. For the given power dissipation, the breakdown is going to be occurring for the larger voltages whenever the collector current is going to be reduces. Otherwise the same breakdown is going to be occurs for a larger currents, it will be occurs for the smaller voltages. That is the meaning. So here breakdown voltage can be increased by reducing IC. By reducing IC is nothing but collector current is reducing. Collector current is reducing is nothing but base width and base doping concentration are going to be increases. So we can say B with 5. B with 5. So A with 3 and B with 5. Next, the cutoff frequency increases. Cutoff frequency we can write like this. Okay, there is a two different types of cutoff frequencies, F beta, beta cutoff frequency, and the other is nothing but F tau by HFE. F tau is nothing but unity gain current, unity gain bandwidth product. So F tau we know. F beta can be written as GM divided by HFE times of 2 pi into CE. CE is nothing but diffusion capacitance across emitter base junction. CE is nothing but diffusion capacitance across emitter base junction. From this one, F beta, the cutoff frequency F beta can be increased. Okay, F beta increases as GM increases, but GM is equal to, we know that one GM can be calculated by using this equation, IC by VT. So as IC increases, GM increases. GM increases is nothing but F beta increases. So cutoff frequency increases as transconductance increases. Transconductance increases as collector current increases. But when the collector current increases, when the base doping is going to be reduces and when the base width is reduced. So for C also, answer is 3. For C it is 3. Cutoff frequency increases as collector current increases. Collector current increases is nothing but base doping and base width has to reduce. So the correct option for this one is nothing but A3, B5 and C3. Thank you.